Okay, good morning, afternoon, or evening, depending on when you're watching the video. So this is going to be day 2 of our derivatives unit. So last day we were looking at derivatives, or not derivatives, pardon me, we were looking at slopes to a curve, okay? And we were using secant lines to estimate or to get it very close to a tangent line. So that tangent line would be the slope at one point on a curve. And that leads us into what a derivative is and what we mean when we talk about the term derivative. So that's what we're going to start with. So a derivative basically represents the slope of that tangent line that we were talking about at a point on a curve. Okay, so let's write the definition down. So let's say derivative. This is or represents, let's say, because that's the best word. Oh, I can't spell here. Rep. Okay, so it represents the slope of a tangent line at a point on a curve. And we'll say that curve could be f of x or if you like y equals something, because f of x and y can be interchanged. Okay, I often use y a lot. Most calculus books will use a lot of f of x type stuff. So I'm going to basically try and define this for you. So let's say that we had an example of, let's get a skinny line in here. Let's say we had the y equals x squared. So we have this curve here. Okay, that's y equals x squared. Now, if we were to take 2 points, let's say we want to get it at point A here. And let's say that this is x and y, or we'll use f of x because that's what the derivative is typically. So that's x and y point. Okay, so this is f of x can equal y as well. Okay, and let's say I won't do it over here, but I'll do it over here. Let's say that we have a point B very close, and it's some distance h away on the x-axis, so that it would be x plus a distance of h, and then f of x plus h. Okay, so if we were to look at the axes here, if I had these set of axes in here, which I'll put in here, let's draw a straight line here. Okay, so there's my x, my y. Okay, and then some distance between from here to here, if we do this in a different color so we can see it a little better. From here to here, that distance in there is h. You moved h away from there. So in that distance, for a derivative to be, that would be your secant line, if you remember, right? So for that to be a tangent line, you have to get b really, really, really close. And the way that we get b really, 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 really close is we take the limit as it approaches 0. We want h to approach 0. So we want this h to get to be 0 so that a and b are basically almost the exact same point, and that's going to give us our tangent line. So if we use this idea of this curve, y equals x squared, is what we're going to use, or f of x equals x squared. And we're going to then develop the definition of a derivative. So the definition of a derivative equation for a derivative is to take the limit. Now we're going to come get some shortcut equations for derivatives later, but this is where every derivative basics thing comes from. It's basically the limit, okay, as h approaches 0. Okay, so that, and then we're going to be using these two reference points here. Let me just flip this over here so that I don't miswrite it. It's going to be, okay, the limit of that. And if we take the slope, which is what change in y over change in x, so it would be x plus f of x plus h minus f of x. Okay, so we'll do that on top because we're going to do the slope because that's what the derivative represents, is the slope. So limit of that of, let's say, the slope is, if you remember slope, I'll put it up here. Slope equals y1 minus y2 over x1 minus x2. So I'm going to do y1 is this one here. So we're going to go f of x plus h minus, okay, this one will be our second one, f of x. Okay, and that's our top of that. Then our bottom is going to be the x's. So it's going to be x plus h minus x. Okay, we can simplify that a little bit because we see the x's in there. So this is going to be the limit as the h approaches 0 of, okay, well, we can't simplify anything here on top, f of x plus h minus f of x over h as h approaches 0. Okay, that's what the derivative is. Oops, let's not put a negative in there. What am I doing? It's going to put an equal, but there's no equal. It's just the limit of that. So the limit of this, I should probably put square brackets around it. Okay, taking the limit of that. So that's our definition of a derivative. Okay, so as you, because that's the slope basically, limiting the slope as you get very, very close to 0, as h approaches 0. So you want to be so close to a with b that you can't even tell that it's a different point, and then you're going to get a very good approximation or slope, which represents a derivative. Okay, so let's do the example that we have here then. How do you plug this in? So using the derivative equation. Okay, so what we're going to do is we're getting the slope of this line. And this line is, this b is going to be so close to here that we're going to get like a slope line there. So it's going to be like, you know, whatever it would be, like right along there. And that's going to represent our slope. So we're going to now use this equation, y equals x squared, or f of x equals x squared in our example. Okay, so let's go ahead and let's go back to green here. All right, so our equation is the limit. Oh boy, I always forget you got to change it. The limit as h approaches 0 of f of x plus h minus the f of x all over h. Okay, so let's say that our f of x is x squared. So now we're going to put in the x squared area, we're going to get what we get. So where we have the x, we're going to put x plus h here. And where we have the x, we're going to put x here. So x squared is our equation. So it's going to be the limit as h approaches 0 of, okay, so we're going to go f of x is x squared. So we're going to put this in. So x squared is x plus h squared. So it's going to be x plus h squared minus x squared all over h as h approaches 0. So let's do our algebra here just to evaluate this limit. Okay, we have to expand out this stuff right here. So the limit as h is going to approach 0 of, okay, this is going to be x squared. And then if we're doing x plus h times x plus h, we have x squared, and then we have xh, and then we have hx, which are the same, so we have 2hx. And then we have h squared minus x squared. I'm going to put it in brackets just because sometimes this is a lot bigger, and then you have to remember to put the minus on, over h squared, h. Okay, what we can do is that these will cancel out because x squared minus x squared is 0. So we are left with the limit as h approaches 0 of 2hx plus h squared over h. Now, we know when we're getting limits, we're going to have to try and cancel out these h's, so we can take a common factor out. So this would be the limit. If we factor out a common factor of h in front, as h approaches 0, of h 2x plus h. Okay, taking the h out of here and taking an h out of here, and then the bottom is an h. Okay, so then these will cancel out, and we're left with the equation now. The limit as h approaches 0 of 2x plus h. So now we can just sub in 0 for h. So there's no bottom part, so we don't have to worry about that. So this would be x, 2x plus 0. So this would equal 2x. So this represents the derivative equals 2x. Therefore, which I use 3 triangles to represent, 2x is the derivative of x squared. And it also represents the slope. Okay, so if we needed the slope at any point, we could now figure out, so what is the slope at x equal negative 2? Well, then we just take this and we go negative 2 times, 2x equals the slope. Let me do this, jumping ahead of myself there. 2x equals slope, so 2 times negative 2. So negative 4 would equal the slope at x equal negative 2 on f of x equals x squared, or y equals x squared. And that's the definition of derivative. And that's our first very simple example. So to get the derivative, you just use this equation. So let's write this out in a nice way, that we're going to use a special symbol for derivative, and we're going to use the definition of derivative equations. So we're going to, I didn't say this equals anything yet, but now we're going to put something out here where it equals, and we're going to use a symbol for derivative. So let's do that here. So then I'll change colors here. So when you're using the definition of derivative, which you won't use very often after this first unit, once we get shortcut methods, you'll use them a lot more. But to understand what the derivative means, it's a slope. It represents a slope at any point on a curve. Okay, so let's say that our derivative then, let's say that f of x prime with a prime like, or if you want to use y's instead of f of x's, y prime means derivative. Okay, so that's our symbol for derivative. So then if we were to write this out, and I'm going to use the f of x one because that's commonly used all the time. So I'm going to use, so then the derivative of any function, f of x prime, is equal to, as we said, the limit as that distance h approaches 0 of f of x plus h minus f of x, all divided by h. And that's our definition of a derivative. So there's our equation for definition of a derivative. Okay, we'll do 2 or 3 examples of it. Here we're on 16 minutes or so. I'm going to look at my notes here for a second. I don't think I have, let's see here. Okay, yeah, look, there's a small practice that goes with 6 questions, and there's 2 kinds of questions that I'm going to ask you. Okay, so let's take a look at the 2 kinds of examples here, and I want to keep this in that 35 minute window of instruction. Okay, so let's do some examples of using this. Okay, now you just use the x squared one. Let's do a much more complex one. Okay, with a couple, with x's around. Let's do a quadratic or something like that. So let's do an example. And this is just finding derivative. Finding f of x prime using the definition. Okay, now we've done x squared already. Okay, we've done x squared already, so you have one example. Let's do a little more complex example. Let's do f of x equals, or y, remember this could be y. Let's go 3x squared minus 5x plus 6. Okay, so there's a full quadratic equation. It's got x's in a couple different parts. And how do we do this? Okay, so we're going to apply this definition. So this definition is, so wherever you see an x, you got to put x plus h first, and then this equation after it, and subtract it over h. So let's do the limit as h is going to approach 0 of, okay, and this is what f of x equals prime. Since that's the derivative, is going to equal this. So our thing is going to be, okay, f, so we're going to go 3 times x plus h squared minus 5 times x plus h plus 6, all subtracted from, now this is where you have to put it in brackets, so that you, and then this whole thing again, because it's just f of x, so this thing, 3x squared minus 5x plus 6. The reason I want it in brackets is because this negative has to be transferred to all 3 of those. And it's all going to be over h. So we have to expand this. So let's slide this up so we can see it a little better now. So we're going to expand this. Now we know that this is x squared plus 2hx plus h squared when we square that, because we just did that with the other one. So let's write that in. So I'm going to say equals the limit as h approaches 0 of 3 times x squared plus 2xh plus h squared in brackets. Okay, and then this is going to be minus 5x minus 5h and then plus 6. And then if we remove the brackets, then it's going to be minus 3x squared plus 5x minus 6. Okay, I've removed the brackets. So I leapfrog that -1 to each of those. So it changes the sign on all those. That's why you got to be careful there. Okay, that's an error that I make. That's an error that many people make when they forget that negative. So keep that in mind. Okay, so we have a canceling here. And we have a canceling here. Because -5x and 5x gives you 0. 6 and -6 gives you 0. That's still there. We have to expand this out. So we're still taking the limit as h approaches 0. And this is going to be equal to 3x squared plus 6xh plus 3h squared minus 5h minus 3x squared. All over h. Now we can see that we've got 3x squared plus and a 3x squared minus, so those cancel out there. So that leaves us with our final, well, not our final, but a simplified expression. Limit as h approaches 0 of 6xh plus 3h squared minus 5h all over h. Okay, so now we have to take that common factor of h out. So h out front, that's 6x plus 3h minus 5 on top over h. Okay, still limit of as h approaches 0, but we're going to cancel this now, and we're left with a bottom, the 0 off the bottom, so it won't be undefined anymore. So we take the limit as h approaches 0 to get our derivative, which remember this is still x prime. We can't see it up there anymore because I moved it up too much. So this is going to be 6x plus 3h minus 5. Let's put a 0 in for the h. 6x plus 3 times 0 minus 5. So our derivative is f of x prime equals 6x minus 5. And that's our derivative for the original equation all the way up here, 3x squared minus 5x plus 6. And there we go. Now, let's do the second kind of example. When I ask you to find a slope of a line or a tangent line at a curve. So we're going to talk about a curve here. So I'm going to do the exact same one that we're going to use this equation, which we already found. Actually, no, let's do another one. We've got 10 minutes yet here, so we'll go and do that. Let's do the second example, and this will be our last thing for today. For example, so sometimes they'll ask you a question. Find the slope of the tangent line of x equal, let's go -3 on the curve 2x squared minus 3x. Okay, so our first step, let me get that to the squared first. Okay, so step one is to take the derivative to get the slope, and then we're going to plug in the number. So the strategy is get the derivative, and plug in x equal -3. So let's do the derivative first. So that's f prime x, or f of x prime, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, so we've got 2x squared minus 3x. So let's go and put that in. Oops, we don't want the f there. We want to put in the equation here. Okay, so the equation is 2x squared. So we got to go 2 times x plus h squared minus 3 times x plus h. Subtracting the whole 2x squared minus 3x. Okay, over h. Now, I am taking the limit of this. I forgot to put that in there. We should keep that in there. Okay, so then this is equal 2 times, remember this is x squared plus 2xh plus h squared. And this is minus 3x minus 3h. This is minus 2x squared plus 3x. All over h. And again, limit of h approaches 0. Simplifying, we can get rid of those. Okay, and then we've got, okay, when we do this, we've got 2x squared plus 4xh plus 2h squared 2h squared. That's leapfrogging that. Okay, we've got minus 3h minus 2x squared all over h. Okay, so we've got, this can cancel those two out. So then we've got 4h, or 4xh, pardon me, plus 2h squared minus 3h, so there's all h's in the top, over h. So now let's take our h out. So it's 4x plus 2h minus 3. Let's see, minus 3h. Bracket over h. Okay, so let's just make sure I was using the right equation there. Yeah, minus 3x. Okay, so now when we do this, we've got to cross this out. And we've got the limit as h approaches 0. Okay, and we've got 4x plus 2 times 0 minus 3. So we've got 4x minus 3 is our derivative. Okay, now the question is asking us, what is the slope of this at x equals, what did I say, negative 3, I think? I should have probably used a different number, but I used negative 3, so let's plug in negative 3. So we go f prime of negative 3 is equal to 4 times negative 3 minus 3, which then would equal negative 12 minus 3, which equals negative 15. So then our slope of that line is negative 15. That's a very sharp slope, and it's going in a downward motion. But that would be our answer. That's a 15, by the way. Okay, and that is our examples for today. That takes us about to 30 minutes, just about. Okay, so just a little summary here. So if we go right back to the top, and then I'll give you some practice from the practice sheets. Okay, so if we take any curve and we take the limit, oh, got a question there. We'll look at it later. So if we look at this, take any curve and we bring a point that is B away from point A, and we want a derivative at point A, what we do is we take the limit of point B minus point A as that distance between the two, H, approaches 0. If we do that, that gives us a definition of a derivative. A derivative is f of x prime or y prime represents derivative, and it is the limit of the function with plugging in x plus h and then subtracting the function f of x over h. We did a few examples of that. And the first example was just finding the expression of the derivative. The second example was using the derivative expression to get a slope by plugging in a number to figure out what the slope is. And that was what we did today. And what I want you to do for practice here, let's just, I'll do it on the next page here. I'm trying to get the bottom bar. You can see I got a whole bunch of stuff open there. But practice. Okay, so it's do like numbers 1, 2, 6. Okay, let me bring the page up here and show you what I'm talking about for your practice here. Okay, now I've got a bunch of stuff open here, whatever. Things will look a little differently because I'm making this in May 2020. So if you look here, it's 3.1, the derivatives assignment. And I put it here, right here for Chromebook people. So this and this are the same as this scan. This PDF scan are these two Word documents. Some people don't have available Word. So if you click on this practice assignment here, there are the ones I want you to do for practice, and then there's your solutions there. Okay, so that's what you can do. Do you have to do all 6? Well, not always, but if you, they're not too hard. If you do 4 out of 6 or 5, if you do 3 out of 6 and you're doing really good, that's probably good for you. But any of those 1 to 6 for practice, just to get yourself going. Okay, so I'm going to stop the recording there, and we'll get into day 3, which will be using some shortcut methods to find derivatives after that. Okay, so we'll see you tomorrow.